Hi everyone, this is Brad Wood. I was having a quick conversation on Twitter the other day talking about how I like to use FusionReactor to identify slow parts of my ColdFusion code. I thought I'd do a quick little screencast just showing some slightly faked but still somewhat real-life examples of helping identifying slow things with FusionReactor. So let's get right into it. I have a ColdBox site that I spun up using CommandBox. I had the FusionReactor module installed. I've activated my developer license for FusionReactor, and I've put some sneaky little slow things into this application, and we're going to figure out what they are. So loading the home page here takes about 9-10 seconds to load due to the evil slow things that I've put in here. Such bad, horrible code. All right, there we go. So that took way too long. Let's figure out what's wrong with our site. So here's a request that just ran. I'm going to assume you have a basic knowledge of how FusionReactor interface works. Looking at our web request history, we see a handful of things in here. The one we care about is this guy right here. This was our web request we made in the browser, and we see it took 9 seconds to run. And it's red because that's just unacceptable, right? Okay, so let's figure out what's wrong. I like this little ColdBox integration here. You see FusionReactor is smart enough to figure out the ColdBox event I was executing. So if we go into the details of our request, the main screen has one thing I always look for right off the bat. There's 1,000 things in here, and you don't care about any of them but this guy right here, total query, total time, which sounds redundant, but it's worded that way on purpose. It's because it's the total of all the query total times. And we see that 3 seconds of our request were spent doing a database call. So that's the first place I always look, because chances are if you have a page that's slow, database calls are one of the main culprits. So you start there. So we know that explains about 1/3 of our slow request time. Out of 9 seconds, we spent 3 of those seconds doing something with the database. The JDBC tab is where we come in to get the details of that. So here in the JDBC tab, we get a list of all the database calls that ran. There was one, and you can see the SQL statement was select sleep 3, which of course is a MySQL syntax for just sleeping for 3 seconds. So that's our first problem. How'd that happen, right? Sleep 3, that's pretty embarrassing code. Little trick here, there's a couple ways to figure out where this is in your code. You can see that it shows you right here actually on main CFC in the handlers folder. Line 7 is where this query was, and you could even expand this little sucker and get a full stack trace of what the stack looked like. Actually, it's not a full stack trace. I take it back. It's a tag context. The ColdFusion tag context, all the CFM files and CFC files that led up to this point of execution. So sure enough, if we go and look in my main.cfc in the handlers, here we go. Query execute, select sleep 3. So there's our first 3 seconds that we squandered away for our request. So that's good. But we still have 2/3 of this puppy left to explain. There's 6 seconds worth of execution. They weren't database calls. What were they? So now we go over to the Relations tab. FusionReactor will track multiple things as transactions. Database calls are a separate transaction. CFHTP calls are a separate transaction. And then it nests them all together here in the interface. And we can see, just to break this down for you, our web request was right here. This was the master transaction. Took 9 seconds. And we have a database call, JDBC request, that we see happen first. Took about 3 seconds. We've already located that guy. We have about 3 seconds or so of mystery right here, right? We're not sure what that is. And then we have another 3 seconds or so that shows up as a CFHTP call. And the HTTP client is just some of the plumbing inside of the CFHTP call. So these are effectively one item. So if we scroll down here, we kind of get a list of our main transaction and all of our nested transactions. So there's the database call, and here is our CFHTP call. So we can see what it's hitting. It looked like it was hitting our localhost site, and it was hitting a main sleeper URL, which of course is a special page that I made that just sleeps for 3 seconds. So that explains the last 3 seconds, but we haven't figured out exactly where in our code we're making this HTTP call. So now we finally get to the piece de resistance that I probably just mispronounced, and that's our Profiler tab, which is what I was talking about on Twitter. So the Profiler tab, let me just back up and talk about this for a little bit. What the Profiler does is the settings are located over here, Profiler settings. What it does is once a request has ran over a certain threshold and FusionReactor says, you know what, this request is slow, I need to take a closer look at it. FusionReactor starts taking stack traces of that thread and storing them. So the default, I've tweaked the default settings here. The default setting is actually 3 seconds. So the profiler won't even kick in until a request is run for 3 seconds. And on production, this is good. You don't want to overdo it, right? Because the profiler does have a little bit of overhead. So after the request has gone for 3 seconds, the profiler kicks in, and every 200 milliseconds, or 5 times a second, it starts taking stack trace, and it stores them all up. It'll also give up after about a minute. If the request is still cranking after 60 seconds, the profiler says, okay, whatever, I'm done. I've seen enough here, right? And that's to protect your server so it doesn't bog it down too much. What I like to do for just local development, where I don't have a lot of traffic and I'm just profiling requests, I'll dial this down and say, you know what, if that request runs for more than 1 second, yeah, sure, go ahead, fire up the profiler. I want to see what that bad boy is doing, right? So here's our profiler settings. And so if we go back to our request history, we'll see there's a profiler link here, and that shows up automatically anytime a transaction runs long enough the profiler kicked in. If we go into the transaction details, we have a profiler tab. They all roads lead to Rome here, right? Same thing. So number of samples, 40. That means that 40 stack traces were taken on this thread as it was running, and those 40 stack traces are combined and merged down into one big stack trace that tells us percentage-wise the breakdown of what was happening during that thread. So first things first, this is an upside down stack trace. The Java lang thread.run is normally what you're used to seeing at the bottom of your stack trace, and then the things that it calls are stacked on top of it. Here we see them upside down. So we see the longest thing that ran, which is the very first thing, and that took 100% of the request and took about 8 seconds. Now, everything else kind of falls down. Just taking the stack trace, grabbed it by the tail, flipped it upside down. Now, the Java lang thread run took 8 seconds, 100% of the time. That's bad, right? Well, it's bad in that request was slow, but the thread run isn't the problem here, right? It's just the outermost call that then called other things that internally were slow. So the rule of thumb is a large percentage or a slow amount of time isn't an issue if the item directly beneath it also has that same percentage. That means you're on the right path, but keep going downward until you find a drop in percentage, right? So we get down here 97%, boom, 59%, right? Okay, so here's a point in the code that we need to start looking to say what was happening right here. I'll also note that our request was 9 seconds long. You'll see we only have 8 seconds worth accounted for in the profiler. Why is that? That's because I told the profiler not to kick in until the request had run for at least 1 second. So these 40 stack traces that were taken, they didn't start until the request was 1 second in. So we only have 8 seconds worth that we profiled, right? And of course, by default, that'd be 3 seconds. So profiling requests shorter than 3 seconds is impossible unless you move that threshold down. So if we dig in here, right here is where the percentages start to jump down, right? There's the signal to noise ratio can be a little low here just because there's a lot of stuff happening behind the scenes in Java, and the trick is kind of learning to look at it and find the patterns that you're looking for to see where the problems are. We can see we have two sort of branches of execution that have large percentages. About 60% of our request was spent somewhere under this call, and about 40% of our request was spent somewhere under this call. So that's what we're going to focus on. So if we dig down into this guy here, you'll see it'll say 36 collapsed methods. FusionReactor does this to try to make this understandable. If you expand this, you can see there's a whole bunch of stuff. Now, this interface has scroll bars, which I hate, so make sure you scroll down the outer scroll bar all the way before you start scrolling the inner scroll bar, or you'll get yourself confused because the horizontal scroll bar will be missing. So here we have a bunch of lines, all with the same percentage, right? So we don't worry about it. Just keep scrolling down. Don't worry about it. Scroll down until, boom, you finally hit the end of the road. This is the guy we care about. This is the guy that took all the time. These calls just happen to be code that called the slow code. So we have lucy.runtime.tag.http. Okay, that's our CF-HTTP call that we saw on the Relations tab. We weren't sure where it was, but we know there's a CF-HTTP call in there. And it says waiting on lock, and the reason is Lucy runs CF-HTTP calls inside of a thread, so it fires off the thread and then it waits for that thread to finish. It does that so it can kill it a little bit more easily. There's our 3 seconds that were represented, about 37% of the request. And if we start here and we look up through the stack trace, we go to the first CFC or CFM file we find, and here we see views/main/index.cfm, right? Now, there's no line number, and that's on purpose. The FusionReactor engineers have to kind of walk a line of not putting too much overhead on your server as they capture all this information. So they don't track it down to the line level for you, but they will get you to the right street. You just have to find the right address. So if we jump over and take a quick look at our index.cfm, oh, that's embarrassing. How'd that guy get there? Right, here we go. In my view, I've got a CFHTP call that calls this really slow URL. Okay, so let's collapse this guy back up. We've identified back over here, relations, we found the database call. We know where that was. We found the CFHTTP call. We had this mystery guy left. What was happening for 3 seconds in the middle? It wasn't database. It wasn't CFHTTP. What was it? So back over to our profiler. Let me hide these guys back down to the default view. So let's dig into the 60% chunk right here. We follow this down and we have about 37%. So we have 3 seconds spent in this branch of code, and we have about 1.8 seconds spent in this branch of code. So this guy is our database call. If we expand him, we can follow these, and you see a bunch of MySQL stuff in the stack trace. This is all that query execute that we ran. So we already know about that guy. We located him. The other branch of code that took 3 seconds is right here. Oh, Java lang thread.sleep. That makes sense. We literally had a sleep for 3,000 milliseconds. So let's expand these collapsed methods, follow up from our sleep till we get to the first CFM or CFC file, and here we go, models myservice.cfc. That's where the code was that had the sleep call. No line number, but it does get us to the file. So if we go look in myservice.cfc, oh, how'd that guy get there? There we go, sleep for 3,000 milliseconds. So that is our missing 3 seconds worth of slowness that was happening right in here in this empty block. And we can use this profiler to drill down, find the slow stuff, and figure out where it was running and see what percentage of the call it was. Now, these numbers, again, are a little easy because I have 3 very obviously slow things inside of a request that's otherwise very fast. On a more quote-unquote real request, you have a number of just slightly slow things. It might not be quite as obvious, but you can kind of click around in here and you can see what part of my request was spending time. And this is super helpful when you have slow stuff that aren't database calls and aren't CFHTP, which are 2 things that FusionReactor kind of natively tracks as separate transactions. But that's the profiler for you. The profiler feature, I believe, is in the FusionReactor Ultimate license. I think I'm right on that, but I do know that it comes in the developer edition, which is what I'm using here on my machine. It comes with the profiler feature. So this is just indispensable for me because if you can capture a request when it's running, you can go and get a stack trace right then. But if somebody comes to you and says, hey, I tried to log into your site an hour ago and it was really slow, well, what do? I don't know. I mean, an hour ago, that's an hour past, right? But 2 of my favorite things in FusionReactor under request are these 2 guys right here, slow request and longest request. So the difference between these is slow request is a rolling window of the last like 100 requests that were 8 seconds or slower. Longest request is an all-time running list of like the longest things. So if somebody had something really slow that happened a few minutes ago, you can go see if it's still in longest or slow request, or if there's very little traffic on your server, it may just still be here in the history. You can click into the profile, and even though the request is long gone, you can see, well, what was that request doing back when it was running? And when it comes to a post-mortem analysis of performance issues, this is just pure gold right here. So hope that gives you guys some ideas, and I will see you all around.